Okay, so this is problem 36 of chapter 21 of Giancoli 6th edition. And this problem is about a transformer. So they gave us, let's write down what is given to us. They give us the number of turns for the primary, so they give us this NP. They give us the number of turns in the secondary coil, so NS. They tell us what is the input voltage, so that means they give us VP. And they also give us the output current, so the current in the secondary coil. Okay, and from that, they want to know what is the output voltage, so they want to know what is Vs. And they want to know what is the input current, so they want to know IP. That's it. So it's not a hard problem, but it's a good excuse for us to review what we saw about transformers, right? So what we said is that, well, the voltage depends on the number of turns, on the number of loops in the coil, so this N here, and the change in the flux. Now, in a transformer, what we have is, we have two sides. One, which we call the primary side with the primary coil, and on the other side we have the secondary coil. So, and we say that the changing flux that both both sides of the transformer feel is pretty much the same. Okay, so here is my primary coil, and this is my secondary coil. So the changing flux is pretty much the same, so I can find equations that connects the primary coil with the secondary. And how do we do that? If this does not change, then I'm going to say that the potential difference, the voltage in the primary, is equal to the number of loops, the number of turns in the primary, multiplied by that change in the flux. In the secondary, I'll have the same equation, but with this index S, apart from the flux, which is still the same. So this is still the same. So now I'm going to connect the two by saying then that this ratio of the primary voltage divided by the number of turns in the primary coil is equal to the voltage in the secondary divided by the turns in the secondary. So this is the equation. So easy, and that's what we need to use here to find the secondary, which is what they're asking, right? The other three quantities here we have. Okay, another equation that we can use is the one connecting the currents. If energy is conserved, then we have that IV for the primary, so IPVP is equal to the energy for the secondary, ISVS, right? And from here, we can also find the other question of the problem, which is what is the IP? Oh, sorry, here. Let's erase this. What we want is the IP here. All right, and you see that with these two equations that we are showing here, this one and this one, you can play with any other combination, any other ratio that you may want. So this is the end of the problem.